Today we're going to be talking about the volume of composite figures. Well, what do I mean by composite figures? Well, a composite figure we'll talk about in a minute. But because we're finding volume, I want to review our formula for finding the volume of a rectangular prism, because that's very closely related to what we're going to be doing today. So here in front of me I have a rectangular prism, and as we can remember, the volume is equal to its length times its width times its height. All right, so we have to find these three dimensions, a length, a width, and height, in order to find the volume of this rectangular prism. I'm going to highlight these dimensions, and finding these dimensions is kind of one of the keys to this lesson. This is the length of our rectangular prism. This is the width of our rectangular prism, and this is the height of our rectangular prism. And as you can see, we kind of go off in three different dimensions. We go off on a left to right dimension. That's our length. We kind of go off on this angle for our width, and then our height is this up and down dimension. We're going to be finding those three things today and plugging them into our volume formula. So let me just erase that quickly. And now first what we're going to be doing is we're going to be finding our length. And our length is the 15, which is this left to right dimension here. We're going to multiply that by the width. And the width is this green dimension here. And then finally we're going to multiply that by our height. And our height is the blue dimension there, the 5, right? And this is going to be our volume. So our volume is equal to 15 times 10 times 5. Our volume is equal to 15 times 10, which is 150, times 5, which is equal to 750. But what is our unit? 750, because these are centimeters, these are cubic centimeters as our unit. So we found the volume using this volume formula, and it's going to be very important that we remember that. So back to this idea of a composite figure. Well, a composite figure, yeah, that's what a composite figure is. It's this figure right here. And you can see that that figure is not a rectangular prism. That figure is it does not have a length, a width, and a height like our traditional rectangular prism. But the good news is we can use that volume equals length times width times height on this shape. But first we have to do something. You may notice that this is actually not one, but two rectangular prisms pushed together. That's what we mean by a composite figure. It is composed, it is made up of two rectangular prisms. If I could take a saw and cut right along that line, what we would have is we would have these two rectangular prisms, and I'm going to call them rectangular prism 1 and rectangular prism 2, and I like to use these Roman numerals to show that. All right, and by breaking it up into those two rectangular prisms, we can actually then find the volume of rectangular prism 1, find the volume of rectangular prism 2, add them together, and that'll give us the volume of the composed figure, of this large composed figure. That's what we're going to do. So let's get started on that. All right, so the thing I did first is I broke the shape into two rectangular prisms, and then I labeled them, rectangular prism 1 and rectangular prism 2. So that means I have to find two volumes. And the formula, as you can see, is right here. But first I'm going to find the volume of rectangular prism 1, and I'm going to write that just like that. And then I'm going to find the volume, I'll do this over here, of rectangular prism 2. And then what I'm going to do is I'm going to add those two together, right? I'm going to add those two together. So let's take a look first at rectangular prism 1. Again, I want three separate dimensions. I need something in the left to right dimension, or called our length, and that's 15. I need something on that diagonal, which is our width, and that is 10. And then I need something that goes up and down, our vertical, that's our height. This is the height of that figure, which is 5. And I now have my three dimensions. The volume of rectangular prism 1 is equal to 15 times 10, 150, times 5, and the volume of rectangular prism 1, therefore, is 750. And of course, the units are cubic centimeters. I'm halfway there. Now I have to turn my attention to the rectangular prism number 2. This is an easy one. Rectangular prism 2 only has the same dimension for all three dimensions, but I'm going to outline them anyway. First, we need a length, left to right. Then we need a width, that diagonal dimension, and then we need a height, which is this up and down dimension. And I can't tell you how often I see the mistake made where children choose the wrong dimension. They choose two lengths and they forget to choose a width, or two heights and they forget to choose a length. Make sure you're taking one of each dimension, a length, a width, and a height. So our volume is going to be 25 times 5, which is 125. Again, this is going to be cubic centimeters. And now we have the volume of both rectangular prisms, and all we have to do is add them together. So I'm going to take the volume of one and I'm going to add that to the volume of two, and that's going to be 750 added to 125, and I come up with 875 cubic centimeters. That is the volume of this composed figure, of the whole thing. Okay, let's review the steps that I just took, because you're going to use them every time. And then we'll do a couple of more problems that are a little bit more complex. Okay, so the volume of composite figures, these are your steps. Number one, you're going to decompose the shape. You're going to break it apart. You're going to break it into two separate, or maybe three separate rectangular prisms, and you're going to label them 1, 2, and if there are more, you would label them 3, 4, so on. Then you're going to find the dimensions of each, and again, it's so important to find one length, one width, and one height for each. Don't take two dimensions, two heights or two widths. Once we have those three dimensions, we're going to use our volume formula, and we're going to find the volume of each. So again, for this, volume 1, volume 2, we just did this problem. And then the last step is, once we find the separate volumes, we're going to add them together, and we're going to find the volume of the composite figure, 875 cubic centimeters. Okay, so these are the steps we're going to follow. Let's take a look at another problem where it's a little bit more challenging, and I'll show you why. Okay, so this one, step one, we said we want to break apart the shape. Well, they've broken apart the shape already. So let's just label that. And I'm going to label this as figure 1, and that's figure 2. So now remember, my goal is to find the volume of figure 1 and add it to the volume of figure 2. Okay, that's what I'm going to do, and that's going to give me the total volume. All right, so why don't we start down here, and I'm going to find the volume of figure 1. And the volume of figure 1 is pretty straightforward. Again, I need a length, and that's pretty easy to find. It's right there. I need a width. That's on that diagonal, and that's pretty easy to find. That's right there. And I need a height. Okay, now I have to be careful. I have this as a height measurement, and I have this as a height measurement over here. But you can tell that this 5 inches is the height of the whole figure. I'm not interested in that. I'm interested in the 2-inch mark. Okay, so let me get rid of that. So 2 inches is the height of figure 1. And now it's just a little bit of math. 10 times 5 is 50, times 2 is 100. So we know I have 100 cubic inches. I'm going to hold off on labeling the units for a minute. Good. Now we need to turn our attention to the volume of figure 2. Okay, now figure 2 is a little bit more challenging. Again, I need 3 dimensions. I need that left to right dimension. Well, I'm looking for that left to right dimension, and it's here, but I don't see a measurement there. However, there are several other widths in this picture that I can use to figure out what that length would be. There it is, right here. It's 2 inches wide. So sometimes we have to search for the left to right dimension. Sometimes we have to search for that diagonal dimension, and sometimes we have to search for that up and down or the height dimension. I have found the length dimension, and that's 2 inches. But now it's time to find my width. Well, my width is here. And again, once again, it's not labeled. It's also here, and it's not labeled. It's also here, and it's not labeled. So I don't have a width. I've got to search somewhere else on this diagram for this width. Well, fortunately, this shape is the same width as shape 1. And right here, this dimension 5 is also the dimension here, is also the dimension here. So that is also the width of prism number 2. So that was a little bit of searching, but we found it. All right, we found it. And again, that's what you're going to have to do. You're going to have to do that careful searching and make sure they're different dimensions. I found one left to right dimension, and I found one diagonal dimension. Now I have to find that up and down height dimension. All right, again, and now you might be tempted to take this whole thing and call that 5 inches as the height. But the problem is 5 inches is the height of the whole shape. It is not the height of just a rectangular prism number 2. So I can't use that. I'm looking for this dimension right here, from here to here. Fortunately, I have some measurements that can help me. The whole thing is 5 inches. We know it's less than that. But how much less is it than that? Well, it's this much less, this dimension here, which is also this dimension here, which is also this 2-inch dimension here. So guess what? This bottom part here is 2. The whole thing is 5. Therefore, this top part must be the difference between 5 and 2. It is 3 inches. Okay, and I'll show you that one more time. Let's erase some of this mess here. Okay, so if I know that the whole height is 5, and I know that this bottom part is 2, and I know that because the height of 2 is right here, then I know that the missing piece here is 3. And that 3, this piece right here of 3 becomes my third dimension. And now I just multiply. The volume of composite figure 2 is 10 times 3, which is equal to 30. So now we have one last step. I've got the volume of figure 1. I've got the volume of figure 2. It's time to add those two volumes together. So going back up to the top, I've got volume of figure 1, 100 cubic inches. I've got the volume of figure 2, 30, and therefore my total volume is 130 cubic inches. Okay? We've got one more to try. All right, so again, our first step, and this one they did not break up for us. So our first step is going to be, how do I break this up? Well, we have some choices. I'm going to choose this way. I'm going to break it up right along that line. And I'm going to have figure 1 and figure 2. And remember, always, step 1 is break it up. Step 2 is let's find the volume of figure 1. Then we'll find the volume of figure 2. And we'll add them together to get the volume of the composite figure. All right, so let's start with the volume of figure 1. 3 dimensions, length, width, and height. Let's see if we can find our length. Okay, our length is our left to right, and there it is, 3, easy. All right, we're going to multiply that by our width. That's our diagonal dimension. That's this dimension here. Problem is, I don't have that dimension. All right, this is challenging. I don't see that dimension. So I'm going to look to my other diagonal dimensions to help me out. So I see a diagonal dimension here of 8. All right, that's the distance from here to here, but it's not the distance, the whole distance that I need. It's in fact, it's this distance here. If I could only find this additional distance here, I could add it to the 8 to get my answer. Well, guess what? That additional distance is here. It's here. It's here. Okay, so that 3 centimeters is the additional distance that I need. So 8 plus 3 makes this an 11, a width of 11 for that particular shape. That's a little challenging, but we have to look elsewhere in the shape to find that. All right, now all I need now is my height. My height is my up and down dimension. Good news, they give that to me. So we had one little tricky step there, but it was not anything terrible. We just had to find that same diagonal dimension elsewhere in the shape to help us. Now it's time to multiply. Okay, I'm going to choose to multiply the 3 and the 2 first because I can do that with the, I can use the commutative property to do that. That's 6 times 11 is 66, and that's going to be 66 cubic centimeters. Time to find volume 2. Volume 2. Let's see how this one goes. Again, a left to right length. Okay, left to right length. It would be tempting, very tempting, to say that that's 11. But 11 is not the length of the figure 2. It's the length of the both figures pushed together. So I'm going to look to other lengths to help me. Okay, I have to look elsewhere. 11 is the whole thing, right? But I want to find just this piece. Well, if I can find this piece over here, I can subtract it from 11, and I can find the piece I need. So that's 11, And if I look here, and I look here, and I look here, I found it. 3 centimeters is this portion of that length. 11 minus 3 means that the part that I'm interested in is 8. All right, so there you go. My first dimension, 8. Next, I've got to find my diagonal dimension. Well, this is an easy one. The diagonal dimension is sitting there right there for me. And then finally, I have to find my height, which is another easy one. The height of the whole shape is 2. It's the same all the way around. I've got my 3 dimensions. All I have to do is multiply. Okay, here I might do 8 times 3 is 24 times 2, 48 cubic centimeters. Last step, volume of 1 plus volume of 2 gives me the volume of the composite figure, 66 plus 48. Add those two together, and I get 114 cubic, well, what are my units? They're centimeters, cubic centimeters. So again, you're going to be breaking the shape up into rectangular prisms, because then we can use our volume formula. You're going to have to search for the length, the width, and the height. Remember, a left to right, a diagonal, and an up and down for each of them. And you might have to do some math to find it, and some might have to do some solving a mystery to find that. Once we find those for each shape, we multiply out the volumes and we add the volumes of the 2 shapes together. All right, there's some practice for you to do. This is a challenging lesson. You can come back to this video at any time. Please do, and good luck.